Hi, I'm Patrick Reagan. Welcome to the Wireless Networking Part 7, Cellular Satellite Technology and Wireless Towers. While we've already covered what you need to know for the exams in the previous wireless networking videos, you don't need this information for the Network Plus exam. However, it will give you some more knowledge on using cellular networks, satellite connections, and wireless towers technology to expand your network. Let's start with cellular technology, which is the same technology that your cell phone uses. The first digital cell phone standard was 2G that offered speeds up to 384 kilobits per second. This standard is no longer being used. 3G, which is third generation, was released in 2001, which offered faster internet connectivity with at least 200 kilobits per second, but up to 2 megabits per second. It introduced mobile broadband, GPS, mobile television, video on demand, and video conferencing. This has mostly been replaced with 4G or higher in the United States and some developed countries. GSM and CDMA are older radio systems used in 2G and 3G cell phones and was the reason in the United States that you cannot use an AT&T phone on Verizon network and vice versa. Global System for Mobile Communications, or GSM, had 90% of the market with worldwide coverage. It is used by AT&T and T-Mobile in the United States. It uses multiplexing where everyone gets a little slice of time. GSM is particularly dominant in developing countries where it provides essential communication services and acts as a fallback technology for developed countries. Code Division Multiple Access, or CDMA, is used by Verizon and Sprint and is popular in the United States. Each call uses a different code, and the codes are used to filter each call on the receiving side. It requires a little bit more processing. Most wireless carriers currently support both 4G LTE technology. 4G fourth generation, which was introduced in 2008, is the current standard. It supports IP telephony, gaming services, mobile TV, and video conferencing at speeds up to 1 gigabits per second. It is based on GSM and edge download rates of 150 megabits per second. Long-term evolution, or LTE, is a version of 4G that has optimized the network for video streaming and online games, and it is used as a stepping stone to 4G. It offers initial speeds up to 100 megabits per second, but eventually increased to 150 megabits per second. LTE-A supports speeds up to 300 megabits per second. 5G, or fifth generation, introduced in 2008, includes faster speeds at some newer lower frequencies. It has launched worldwide in 2020. It promised to transform mobile communications and enable a wide range of new applications and services. It offers speeds from 100 to 900 megabits per second, but it will eventually reach up to 10 gigabits per second. Latency in 5G networks can be as low as 1 millisecond compared to around 30 to 50 milliseconds in 4G networks. This lower latency is crucial for applications requiring real-time responsiveness such as autonomous vehicles and remote surgery. 5G can support a much higher number of connected devices per unit area compared to 4G. This is essential for Internet of Things, or IoT, where a massive number of devices need to be connected simultaneously. When using a cellular connection for your network, ensure that the network device used to connect to the cellular network is compatible with your carrier, such as Verizon, AT&T, and T-Mobile. Use an activated SIM with a data plan that supports LTE or 5G routers or machine-to-machine or M2M usage. A LTE 5G wireless WAN router is a network device that provides internet connectivity over cellular networks, including 4G LTE or 5G, instead of or in addition to a traditional wired WAN connection like fiber, cable, or DSL. It distributes internet access to connected devices, wire to wireless, and provides failover and load balancing by automatically switches to cellular if wired internet fails, or balances across WANs. Some of these devices will accommodate multiple SIMs from multiple cellular connections for redundancy. Many of these devices provide Wi-Fi access, and many of these devices include firewall, VPN, NAT, and sometimes advanced SD-WAN features. Use cases include it can be used to provide mobile connectivity to support vehicles, such as buses and police cars that need to have internet on the move. It can be used as temporary locations for temporary sites, pop-up stores, events, or disaster recovery setups. It can be used to provide a failover network services. It can be used for IoT deployments that connects remote sensors, kiosks, ATMs, and cameras. Examples include Cradlepoint, which is enterprise focused with NetCloud management, PepLink, Max Transit, and BR1, which is popular in mobile and multi-WAN deployments. The Cisco Meraki offers 5G cellular gateway and Meraki dashboard. Sierra Wireless AirLink XR80 is a rugged LTE 5G router for industrial and public safety. And lastly, Tectonic has an affordable LTE routers with industrial features. Now let's move to satellite technology. Satellite is a form of radio or microwave networking where it is non-terrestrial communications using high frequencies 1 to 30 gigahertz. Satellites can provide coverage over vast geographical areas, including remote and rural regions. Satellites may be necessary for remote sites and difficult to network sites. Similar to other microwave communications, satellite communication requires a clear line of sight between the transmitting and receiving antennas. It has high cost relative to terrestrial networking. Typical speeds may be 50 megabits per second down and 3 megabits per second up. Due to the long distances that signals must travel, from the Earth to the satellite and back, satellite communications often experiences higher latency compared to terrestrial microwave links or other forms of communication. High latency is 250 milliseconds up and 250 milliseconds down. Because of latency, jitter may occur, which is caused by the variation and delay of packet transmissions over a network. A satellite refers to a type of communication technology that uses satellites orbiting the Earth to transmit and receive data. It's part of a broader category of wireless communications and especially useful in areas where traditional infrastructure like fiber optics, cable, or cell towers is unavailable or impractical. A satellite is a space-based device that receives signals from a ground station called an uplink and sends them to another location called a downlink. It essentially acts as a relay station in space. Use cases include remote off-grid locations, redundancy for disaster recovery, maritime or aviation applications, and military or field operations. LEO satellite, such as that used by Starlink, are currently the most attractive for general-purpose internet due to lower latency and higher throughput. The lower latency is because it has the lowest of the orbit altitudes. Satellite dish or terminal is specific to a provider. Satellite terminals have specific install alignments and power needs. It needs to have a line of sight to the satellite with a clear view of the sky with no obstructions like trees or buildings. You have to mount the dish securely in a non-interfered zone. The modem or router is usually provided by the satellite company or integrated with the terminal. The power source is especially critical in remote or off-grid areas. Consider using uninterruptible power supplies or UPS or solar backup for remote off-grid locations. Some countries require a license or registration for satellite communications equipment. Check import-export laws, especially for mobile or tactical use. Expect higher latency compared to normal wireless Wi-Fi. Geostationary satellites, which is approximately 35,786 kilometers altitude, have approximately 500 to 700 milliseconds round-trip latency, while LEO, low Earth orbit satellite, have approximately 20 to 50 milliseconds, but still higher jitter and variability than fiber or cable. Satellite data is often metered or has been lower throughput than wired or cellular connections. You should implement quality of service policies to prioritize critical traffic. Use traffic shaping to limit non-essential bandwidth, including software updates and streaming. Apply compression and deduplication techniques to reduce payload size. Use data capsule learning and monitoring tools to help control costs. Since satellite links are shared infrastructure and susceptible to interception or spoofing, you should consider. Use end-to-end encryption such as VPN, IPsec, and TLS. Harden endpoints and firewalls against man-in-the-middle or packet injection attacks. Employ firewalls with deep packet inspection. Satellite links can be more susceptible to interception and jamming in certain scenarios, especially in conflict zones. Since satellite links may suffer from weather-based degradation or periodic signal loss, you should consider using dual WAN routers with cellular or terrestrial failover, configure BGP, BRRP, or SD-WAN to dynamically switch traffic paths, and use out-of-band management if satellite is the only path. To increase performance, deploy edge caching for web content, video, and system updates, and use proxy servers or CDNs for content acceleration and quality of service to shape traffic to avoid congestion. Prioritize critical services. The last topic is using microwave towers in your network, which are used to connect two line-of-sight points that don't have normal network connectivity available. Setting up microwave towers for network connections is all about line-of-sight wireless communications, is fast, reliable, and often used in telecom and enterprise backhaul. Microwave towers use high-frequency radio waves, typically between 6 GHz and 42 GHz, to transmit data over long distances without cables. Licensed microwaves offers better protection from interference, which is used by carriers or ISPs. You must register license link with local telecom authorities. Unlicensed bands, such as 5.8 GHz and 24 GHz, are cheaper but riskier in congested areas. Throughput can range from 100 megabits per second to several gigabits per second, depending on hardware and spectrum. These are point-to-point connections are between two fixed antennas. Key requirements include line of sight, which must be tall enough to provide unobstructed path between towers with no trees, buildings, or hills. You should include Fresnel zone clearance, not just a straight line, but a 3D elliptical area around the path. Even if two antennas can see each other, objects inside the Fresnel zone like trees, buildings, or terrain can reflect, diffract, or absorb the signals, causing interference or signal loss. The Fresnel zone refers to elliptical area around the line of sight between the two antennas where radio waves can travel. You should use elevation maps or tools like Radio Mobile or a BigQ2 AirLink for planning. You also need a solid structure base to support the antenna, and you'll have to have power available. Consider solar and batteries if you're off-grid. Towers can be used for point-to-point, which is a single link between two sites, and point-to-multipoint, which is one tower connected to several others, such as a hub and spoke. For redundancy, you should consider failover paths or ring topologies. Hardware needed includes parabolic dishes or antennas, which are highly directional, microwave radios and transceivers, mounting structures including towers, poles, and rooftops, grounding and lightning protection, and router firewall for edge networking. Popular brands include Cambium, Ubiquiti Air Fiber, Microtik, Ceragon, and Radwin. Skills needed to set up microwave towers require specialized skills and expertise, include beyond basic construction knowledge, technical skills related to radio frequencies and microwave technology, electrical skills, and the use of testing equipment including spectrum analyzers and bed error rate testers. It also requires tower climbing and rigging skills and not being afraid of heights. Environment considerations include rain fade, especially at higher frequencies, temperature and humidity extremes, and wind loading on towers and dishes. You need to design with climate tolerance and wind resistance in mind. Cost considerations include initial investment is moderate, although it is usually cheaper than laying fiber in these undeveloped areas. It requires maintenance needed for tower safety and equipment aging, and you may need to pay licensing fees if used licensed spectrums. For testing and monitoring, do a link budget calculation to show what is the expected signal strength versus losses. Use spectrum analyzer to detect interference. You need to continuously monitor link uptime, throughput, and latency. Security best practices include using AES encryption that is built into many radios. Disable unused services or interfaces and implement firewalls and strong authentication. Lastly, keep firmware updated. Question: the latest standard for cellular communications is called what? Answer: 5G. Question: which of the answers listed below refer to the characteristic features of satellite internet connections? Choose three answers. Answers: high signal latency, interference, weather dependent, and relatively high costs in comparison to terrestrial links. Question: which has the highest latency? Answer: satellite. Question: when setting up two microwave towers, besides line of sight, what free path do you need for a good wireless signal between two towers? Answer: Fresnel zone. For more information, visit these sites. In summary, LTE 5G wireless WAN router is a network device that provides internet connectivity over cellular networks such as 4G LTE or 5G instead of or in addition to traditional wired WAN connections like fiber, cable, or DSL. A wireless WAN router distributes internet access to connected devices, wired or wireless, and provides failover and load balancing while automatically switches to cellular if wired internet fails or balances across WANs. Satellite is a form of radio or microwave networking where it is non-terrestrial communications using high frequencies from 1 to 30 gigahertz. Satellites can provide coverage over vast geographical areas, including remote and rural regions. Similar to other microwave communications, satellite communication requires a clear line of sight between the transmitting and receiving antennas. A satellite refers to the type of communication technology that uses satellites orbiting the Earth to transmit and receive data. LEO satellites like Starlink are currently the most attractive for general purpose internet due to lower latency and higher throughput. Expect high latencies with satellite connections. Setting up microwave towers for network connections is all about line of sight wireless communications, which is fast, reliable, and often used in telecom and enterprise backhaul. Microwave towers must have a line of sight with an unobstructed path between towers, including Fresnel zone clearance, which is a 3D elliptical area around the path. Thank you for watching this video. This completes the wireless networking series. The next series will be the TCP/IP. If you have not already, subscribe to the Pat Hatcher Back channel. Thank you.